My name is Mariam Abdullah.
طلال الشحي.
Abdullah Shahi.
You are welcome all, and we are happy to participate with you. We will talk about design and programming. After reviewing the robot game rules, we conduct a study on the design to be created, and we have asked and received the following question. Does this rule restrict our design? Is there a limitation to the size of the robot? We thought about all tasks that our team have decided to do. We thought about the path that our team decided to follow in principle, the initial strategy, and we discussed about them. Does this path need the following line, the ending one, the following one, or the ending line? Then we design a basic robot to match the feature we want to need. And at the end, this is the robot that we have designed for this year. FLL challenge under the title Replay. This robot is balanced. It's in its design has strong structure and breakable, suitable for speed, strength and accuracy in all target tasks, and small in its size because there is a small spaces between the tasks close to each other, whereas if the robot is large in the size, it will cannot move smoothly and execute the task accurately.
In our design for this robot, we made the optimal use of the necessary parts, which made its installation simple and uncomplicated, and thus easy to repair and maintain. The robot can be flipped in all directions without breaking any our design for the robot. The screen can be read and the buttons are easily accessible. Our robot has straight slides in order to facilitate its position in the right place at the starting area. As well, when it is leveled against the wall and it's able to move as planned without any interference. We use two front light sensors to track the black line to execute the task with the required accessory. We use the gyro sensor inside it to allow the robot to rotate with the required accessory according to the programmed angle. We also use four motors, two for the movement of the robot and two additional smaller motor in order not to be a burden on the robot in terms of plans as the small motors do not take much space in the structure of the robot. Unlike the large motors, we used back traction to move the robot forward and used 5 attachments to carry out the task, which can be placed directly on the robot in a short time.
We used gears to transfer the rotational movement from the axis of the motor installed it on other gears attached to the parts of multiple directions. In designing the model, we avoided the mistake what we have the proposed conventions, as it's very easy to put the entire model on the robot while carrying out tasks in the short time. We tried to integrate a large number of tasks into one model. The mechanical design made it easy for it to perform that task accurately and also in programming. In our strategy, our discussion was about what are the tasks that are close the base and can be done quickly? What tasks can be grouped together due to their proximity? Are there some tasks difficult to access? What are the team's goals for this year when it's coming to playing robot? How many points for each mission? We tried as much as possible in our strategy to implement the largest number of tasks close to each other in one go while starting the robot to save time. And we encountered many problems during the design of accessories. We followed the strategy designing accessories for each task separately. And then we integrated a certain number of attachments in one task in final design. Here is difficulty. Because in the final design, the size of the attachment must be taken into account that is not greater than the area of the launch base. And also the legal height of 30.5 centimeter must be taken into account, as well as the good distribution of the weight of the part on the robot to ensure the proper functioning of the robot in the stadium.
Since there are only two motors, we had difficulty how to employ mechanical design in carrying out some tasks. We have written our programming in form of simple, easy to understand units blocks that anyone can understand and always lead to the same result as planned. We shortened the time between one task to another to gain time by setting the programming of the robot's launch in the switch. When the robot returns to the region, it is sufficient to press one key in the brain to execute the robot for the next task. This enabled us to gain time as a strategy to follow. We have programmed the robot to return to the home area while each mission is finished to avoid deducting the accuracy points. Through our strategies, the robot's behavior on the pitch is using sensors such as color, light, and rotating sensor, gyro sensor, as well as alignment of the following wall, as well as alignment on the wall, as well as throw alignment at the base of the launch to get a good start and carry out the tasks with accuracy and smoothly. To perform tasks, there are a number of steps in programming. The robot must move to one place and perform a task and then move to do another task, integrating the implementation of task programming according to the strategy followed. We used motor rotation to ensure that the robot reached the precisely set point. We used 5 programs to carry out the tasks. During our task programming, we used sensors to ensure that the robot reached the target accurately. We used the light sensor to trace the black line and naturalize it to correct the path of the robot. And by designing balanced parts on the robot's body to ensure the tasks were executed with high accuracy, and we also used multitasking program segments that run at the same time to save time.
In programming, we have programmed cranes and straightening the robot on the wall and on some stadium model. We have improved time management while programming the fast execution of tasks and placing the parts of the robot, as well as in programming using the multitasking feature and executing the task close to some. We programmed each task by giving it a long time to execute in the early stage, and then we gradually shortening the time. We change our strategy to play the robot many times over time when getting a new idea or finding way to combine tasks.
In our strategy to ensure good and proper mobility of the robot in the field, we have used the following techniques: alignment at the base, alignment of the black line following line, align a wheel following wheel, return to the wheel to help the robot to correct the accumulated error, reduce time to base to complete the largest possible number of tasks.
This is our main code that we used based on our mechanical design and strategy. We shortened the time between one task to another to gain time by setting the programming of the robot's launch in the switch. When the robot returns to the region, it is sufficient to press one key in the brain to execute the robot for the next task. That enable us to gain time as a strategy to follow. We like the most starting point, and we collect more points with 140 points, which is the last task. We call it the step counter. During this breakthrough, the robot performs the step counter task and get 20 points, then execute the task pull up bar and get 20 points. Then execute the mission push and gets 60 points. Then execute the mission weight machine and collect 20 points. Then the robot dance mission and collect 20 points.
In conclusion, I thank you all and goodbye.
Goodbye.
Goodbye.